Hi guys, I wanted to make this video on how to use an oscilloscope because there are no good videos online. They're very confusing. They go into technical jargon that you really just don't need when you're starting out. And so I'm just going to go into the bare basics, all right? So the first thing you want to do is just turn on your oscilloscope. And while that's doing its thing, you can pull your first set of probes out of the box. Just pull out one set of probes. This is a SDS 1104XE. This is made by Siglent. This one can do 100 megahertz at 1 gigasample a second. So for those of you who don't know what an oscilloscope is or what the heck I'm talking about with 100 megahertz, basically when you're working with electronic devices or anything that has to do with a signal, and you're trying to see everything that it's doing within, say, 10 seconds, this can show you. But typically, these are used to show you much, much smaller. So if you're trying to look at what the circuit is doing within, say, 1 microsecond, then you can do that on the oscilloscope. It can be really short time frames. All right. So we're gonna go into that type of stuff. So this one, if you have a signal, say coming out of this signal generator I have here, like a square wave, which means the voltage goes up and it's on for X amount of time, and then it goes back to 0, and then it's off for X amount of time, and then it repeats the cycle. That'd be a square wave, right? So with a square wave, you can measure that on here, for instance. Now this is an NE555. This is a monostable mode. This will do a square wave. And so I'm going to show you that square wave using the oscilloscope so we can see if it's clean or not. And it can also be used for troubleshooting a lot of other things like radios and just tuning maybe a Tesla coil, whatever it may be you want to do. So after it's turned on and you have your probe pull out of the box, these aren't really accurate when you first get them. You have to tune them. So if you look at the part you plug into the actual oscilloscope, there's a little hole here, and you will stick the little plastic screwdriver it comes with into the hole and either turn it counterclockwise or clockwise, and just do it very small increments at a time, and then that'll adjust it. Mine's already adjusted, and I've been having issues de-adjusting it basically, so then I can show you what it looks like when you tune it. But when you first plug this in, this is called a BNC connector. So there's little notches here. You line them up with the ones on here. So just pop it in and push it and do clockwise turn, right? And if you don't know this already, most scopes will have little feet that you can pop out, you see, on both sides. And so you'll then take your little clip and you can pop it like this, and you can even turn the clip around as you're holding onto it. Put it on the one side. It has square edges, and it says cal above it, CAL. It stands for calibration. That's going to output a signal. So this little clip right here I'm pulling down, this always sees positive voltage. Okay. And keep in mind, you never want to exceed the voltage that the probe can handle or the scope. Okay. Because you're going to damage components. It's not going to be pretty. Now this is the ground clip. This should never ever be connected to a positive voltage. Now if you connect it to a relatively small voltage, you probably won't have many issues, but I'm talking really small. And the reason for this is, if you connect this up to, say, a live voltage straight out of your US wall outlet, this is actually ground. Now there's a ground on the oscilloscope. If you connect this to live, say 120 volt coming out of the North American outlet, what will happen is the 120 volts electricity will travel through here to true earth ground, and it'll do so extremely fast, drawing as much current as the wall outlet can dump, which is about 15 amps. So that's going to I've heard that it can blow up the scope. It can blow up the oscilloscope. Now, I'm not really sure if, I don't think the oscilloscope would actually blow up. They have fuses and stuff. but just don't do it. Just don't let this touch a voltage source because you don't want any current across it. And when I was starting out, I really didn't know much at all. Like, I thought I would connect this to a positive voltage, and that, like, the resistor in here maybe couldn't handle the voltage or whatever. But you have to remember that that it couldn't handle the current or whatever with the resistor in here. But you have to remember that this thing is it doesn't measure amperage, it measures a voltage. So you don't have to worry about things like this. Just remember, do not connect this ground clip to anything but negative. And if you want to make sure that you're doing what you're supposed to, then it's very easy. All you have to do is just take a multimeter like this Coweights one I have, and you just set it to voltage, and then you can measure. Now, if you're working with alternating current, you can't exactly see which one's positive and what leads negative. Or what they call it in AC is like, you can't tell what's live and what's neutral. Using a DC, if you're measuring with DC, then if you're playing with DC, then you can see what's positive and what's negative, and then you can safely not only see the voltage to make sure it doesn't exceed the scope of the probe, but you also make sure that you don't accidentally connect this to live. There's a lot of confusing videos saying don't connect it to, don't measure mains using your oscilloscope. And that's not true. I have personally measured mains. It is possible. You just need to be very careful and make sure that this does not accidentally hit live, because there is no redos. It's just bad things are going to happen instantaneous. Electricity travels, I believe, at the speed of sound. So, yeah, you ain't going to be able to react. You're just going to see things on fire or whatever. So you have this all hooked up. Just take this, as I mentioned before, stick it in the hole, gently twist it left or right so you see the thing correctly. Now, before you do this step, we have to take this and, like I said, hook this up to the thing that says Cal, which outputs the signal here. So it's a positive signal, and there you see it already showing. And then we need to ground this, and you can put that to the right of it on the little, this is chassis ground. That's what that weird symbol right above it is. And this has the round edges. So I'll just do that now. And now if you don't see this already, or even if you do, it's good just to push auto setup just to make sure you're actually seeing the proper signal. So there you go, there's your signal. And again, I just pushed auto setup, it's blue here. I'm gonna move this in so you guys can see a little better. Let me just get some of these things out of the way real fast. I don't want to overwhelm you guys who are new, like I was new, with all this electronic equipment I have, because I mean, you're just trying to start one thing at a time. So I got this thing off Amazon. It was about $500. It's 4 channels. So I'll talk about the channels now. So now that we've seen what this is, this is one type of signal. It's coming in on channel 1. See the 1? You can view multiple of these signals. You can view multiple different signals simultaneously on this same graph right here using different channels, and that's why it's beneficial. I'm not sure why having multiple channels like actually is beneficial in electronics and why you'd want to see different signals, but I guess they make it because people use it. I'm just not that experienced to know what to use it for. I do know, however, though, that they either come in 2-channel or 4-channel. Now that you have your signal, we want to be able to work with it. We want to be able to, like, you know, do surgery on it and see parts and see if it's good. So if you take your horizontal here, you can turn this to the right and that'll zoom in. So now we're viewing the signals, the pulse width, which is the time that it's on to the time that it's off. See how it goes down to off? This is off and this is on. And then you can turn it left to view it at a higher time. Now we're at 1 millisecond versus the 100 microsecond we were at. So you can really zoom into the signal to get really far into it. Now, mine probably looks different than yours, which I forgot to mention. Let me turn on a setting, and then I'll explain it in a minute. So sometimes these, oh, there we go. I just had to give it a minute. So, oops. Okay, yeah. So now I'm going to rerun the auto setup. Okay, so here we are. So this is typically... So this might be typically what your signal looks like. Something like this. And it's very annoying because... So you have... Let me explain. So you have a position knob. You have two position knobs. One, it goes up and down vertical, and the other left and right horizontal. And you can see yellow is for horizontal and blue is for vertical. Now, that is to move the signal up so you can feel like the top of it or the bottom. And then the position moves it left and right. See, I'm just turning this left and right. This is the position knob. If you push the position knob in, it zeroes out the horizontal. And if you push the other position knob, the vertical position knob in, then it resets the vertical, right? But let's say, I mean, the signal is really tiny. I want to zoom in, you know what I mean? We want to do surgery, right? So I'll just adjust my vertical knob. Oh no, look what happened. When I went from 1 millivolt division, and by the way, you can see the division right here. 1 volt. See, this is 1 volt, and then I moved into 500 millivolts. And there's 1,000 millivolts in 1 volt. So now I'm at half a volt. It just went off screen. And if I adjust the position knob, now I can go back. But now, if I zoom in even more, you can see I can't get to the top anymore. Well, I can, but it takes a long time. And then if you zoom in again, see, now I've reached the vertical position. I can't even, like, it won't even let me go up. And then I can redo the position. I can't even go down with the signal. So it's causing a lot of issues. So to fix this, you click on the channel number you're using. So like this is on channel 1. So I'm going to click 1 for channel 1. And then now it's actually going to deselect it because I already selected the settings for channel 1. So I'll click it again. But if there's no settings down here, click it and it should bring up this menu. You can also click this and it should toggle or hide the menu. But if you don't see it, then click channel 1. And then again, like I said, if you accidentally turned off channel 1, now there's no light, click to turn it back on. If it has the light, it's showing, right? And then what you want to do is there's something called coupling. And so that tells it what to read the signal as. So it's going to read it like it's AC. So I'll just click it one more time and boom, there's AC. And now there's this thing up here. You can click select or you can just click the menu button. But you can click select here and then voila. And now you can toggle the menu or keep it, whatever your preference is. So now I'm going to click auto setup again. And there's my signal back. And now you can see I can easily adjust the vertical position knob. And then I'll just zero it. Now when I zoom in, look what happens. You see, as I zoom in, it will still go off screen, but it's perfectly, it doesn't like move up. You see what I mean? It goes like this. So versus the other one. And now if I do the horizontal, see, everything is just so much more smooth. However, I believe doing this setting, the volts that it's reading does become less accurate. But this is an extremely useful setting. So like I said, if you just select the channel, boom, it brought up the menu. I can change my coupling. You can also turn this instead of just pushing this. So if I turn the intensity adjust, I can also select what I'm reading. For some reason, you can read something as ground. I don't know what that does, but you can do AC and then you can go back to the DC. So now what I'll do is I'm going to show you the signal coming off this NE555, okay? So let's do that now. I have a power supply that you cannot see, it's out of frame, and I'll just put it here. I'm running 3.8 volts through this, and you can see LEDs blinking. And then I can tune the potentiometer, and I can blink it slower. But the question is, what frequency is it blinking at? And you can use math to do this, but some circuits you really need the oscilloscope, right? So what I'll do is I'll disconnect all my things. And the first thing I'm going to do is connect my ground, because I want to make sure, again, this doesn't connect to the actual voltage by accident, the positive. So I'm just going to do this first so it's out of the way. and I don't get sidetracked and then accidentally connect it because I wasn't thinking. So this is negative. Again, you can measure with your voltmeter just to be sure. And then I can connect this to anywhere in the circuit. I could literally connect it to the exact same point as ground. I wouldn't get a signal. However, for those of you who are crazy like me and just love to know things, you can connect this anywhere safely and nothing bad's going to happen. Like anywhere. Again, as long as you don't exceed the maximum voltage that the probe and the scope is rated for. This particular model I'm using is rated for 400 peak. Okay, I'm not going to explain all that, but it's rated for 400 peak. For an example, this is a RMS. This does not read peak. I want to see if it says it on here. It probably does not. But, oh, right here, true RMS. So these read RMS, and these do peak. But anyhow, that'd be a topic for another video. So now I'm going to connect this on the positive lead of the LED, because that's where the signal is coming out of, which is just after the resistor. I want to see the signal that the actual LED is getting. And so now we got something, but again, where is it? I'm going to push auto setup, and I'm going to have it find the signal for me. Voila, there's the signal. Not a square wave, right? It's not a perfect square wave. Kind of interesting, right? So now we can see what the real thing is. Pretty cool, eh? So, again, you can play around with your voltage divisions. And now this is 500 millivolt divisions. So I'm actually going to see... I'm wondering if I'm wrong about this, but if I click on the... again, I have to select channel 1, and then I can change from coupling to, well, DC coupling. And then I can change the millivolt scale. It says 0.0 volts. It can't go as small as this. That's kind of too bad. I say that stinks. Anyhow, but so let me give you an example, I guess, of reading voltage, because don't get confused. This is the voltage division. So each square right now is 1 volt. So if I have a signal, and it's coming up to this square right here, then that's going to be 1 volt, 2 volts. So because it's occupying the second all the way up to the second square, and each square is 1 volt, and it's in 2 of them, it's, you know, 1 square plus 1 is 2 volts. So it's 2 volts. And if you change the division again, like now each is 200 millivolts. So if it's all the way up here, it's at 400 millivolt. And that's why the signal elongates as you zoom in. Cool, right? So now I've got the DDS here. I'll just turn this on, and I'm gonna remove this because I have a special, just a minute. I have a special connector. This is BNC to BNC. So I can just straight up, and you're probably not gonna have this, but I can just straight up connect this to my channel on this, and then I can connect it to here, right? And then I'll do auto setup, and there, it's outputting a sine wave. It's pretty dang clean too. This is only $100, good deal. So now, now if you see here, let me just shut off my power supply. Don't waste power, it costs me electricity. Not much, but you know. So now you can see I can adjust this. And you should be doing, now this is an actual AC signal. You can see you can adjust, and if I go on here, I can adjust tons of things. I can do a square wave, or just, there's lots of possibilities, right? I can do a sawtooth. There's like an arbitrary wave I can do. I think there was like a dirty, this is just plain old DC. So if I change the amplitude here, it should start increasing on the thing. I don't know why it's not, but anyhow. So this is a Lorenz wave. Here's a sync, multi-tone. it's just got, here's noise. So you have noise in your circuit. You can really zoom into the noise and see what's going on here. Again, you can change the vertical and stuff. Kind of interesting. They've got a bunch of cool things, but that's not what this video is about. So I'll just go back to the sine wave. So here's the sine wave I have. I'll just push auto setup so it looks good. Excuse me. So well, sorry, I should do the square wave. So the reason I'm doing a square wave on this device is because I can change the actual voltage that comes out all the way up to like 20 volts. So so this is on AC again, so it's reading 0.0 volt DC. We can click on this. Oh, coupling was actually coupling was DC, very interesting. There's also this trigger feature here. This tells it when to start the signal. So if you put it out of range, you get some very weird results. So if I start it right here, then the waveform starts. And depends on the trigger. Like if I'm gonna trigger, if I set the trigger to be like, see, it tells you all these settings right here. You know, trigger when an edge crosses between two thresholds. So if I did this, for instance, then you could literally, and if you click this in, then it's 50% duty cycle, right? I'm not really sure actually how to change, select which thing. It's triggering on the rising slope. But you've got a lot of good things here. If you zoom in far enough, you can see that eventually it doesn't rise, and that's why when the signal's down here, it's going really weird, because it looks like it's rising until you zoom in, right? So you just put it on like really 50% of the signal is what you want, but you can just, it's on auto right now. Let's put auto setup. So there's some settings like this that you can do, which are really funky, I guess. But yeah, that is the bare basics of an oscilloscope. So I really hope you enjoyed the video. And yeah, it's a great piece of electronic equipment. I definitely recommend you save up for one. You can do a lot of good stuff with it. So it took me a while to save up for mine, but I was really excited. I wish there were better quality videos. I just made this video. I wanted it as simple as possible for people like you. So let me just you can see what happens when I adjust the offset voltage. This is the offset from the negative. Now the offset's going higher than the actual thing, because my thing is an offset on here. Offset voltage from 0. You know, which can be quite handy. But anyhow, we can just, still don't know what's up with the this probe is not really a probe, so I just set it to 1x, you see. You've also got multi-pages, like you can change unit to volts or amps, because there are ways to measure amperage, kind of. And then here's where you adjust this thing. See, I didn't even know there was this. See, I could just set the offset to the max. This one, you don't touch the display. There's not any settings for that. I just put it default now. You can put like labels and all that weird stuff, but the signal should be starting here. I think it's kind of stuck on AC right now. So I'll just remove this signal and re-auto setup. Yeah. You can see AC and DC, they don't even change. I bet it would fix if I powered off, or maybe I re-defaulted my settings. This is the default button. If you mess up some settings, you can just re-default. And push auto setup here. Yeah, it doesn't do its thing. But anyhow, a good video. Hope you guys enjoyed. See you in another one.